Good day everyone, welcome to JD's channel. Today, we're going to discuss another topic. Don't forget to like, share, and subscribe for more tutorials. Thank you and God bless. Hello guys, welcome again to JD's channel. And for today's topic, pag-usapan natin itong statically indeterminate members. Okay? So, again, let's get started. Okay, so ano ba yung ating or ano ba yung contents ng ating pag-uusapan ngayon? So, una is, what is statically indeterminate member? Ayan, nilagay ko yung C. Ayan, so ano po? Statically indeterminate member. And then, secondly, we will discuss the procedure for solving statically indeterminate member problems. Okay, and then thirdly, we will solve. Okay, so we will proceed to our solving problem right after matapos natin yung mga theory and discussion with regards sa statically indeterminate members. Okay, class, so for introduction, in statics and structural mechanics, a structure is statically indeterminate when the static equilibrium equation, force and moment equilibrium conditions are insufficient for determining the internal forces and reaction on that structure. So that is what we call statically indeterminate class, when the equation or equilibrium equation, yung ng forces and movement under ng equilibrium condition is or are insufficient para malaman natin yung mga internal forces. Okay? So, what is statically indeterminate member? So, ang sabi din dito, when the reaction forces or when reacting forces or the internal resisting forces over a cross-section exceed the number of independent equation of equilibrium. So, yun yung sinasabi natin na statically indeterminate. So, katulad lang sinabi natin sa ating introduction kanina lang. Okay? It is also the condition where the equation of equilibrium are not, ayan, so yun nga, insufficient nga, or not sufficient to determine all the reaction on a member or doon sa structure. These cases require the use of additional relation that depend on elastic deformation in the member. So, sa mga nakaraang discussion natin, or sa nakaraang tutorial, we discuss yung ating mga deformation. Ano po? So, yun. We discuss yung mga formula natin na ginagamit sa deformation. So, ngayon, class, ayan. Yun ay ating gagamitin din. Po. Ayan. And now, proceed tayo, class, procedure for solving statically indeterminate members. Yan. So, una daw, class, is that draw the required free body diagram and derive the equation of equilibrium. So, syempre, pinakauna naman natin ginagawa lagi is have this FBD, okay? Sa lahat ng pag-solve natin ng ating problem. And then, ayan, so derive natin yung ating equation ng equilibrium. So, alam naman natin yan, since sa statics, we have the summation ng f of x, f of y, and the summation ng moment natin. Then the next one, class, is derive the compatibility equation. Ayan. Again, the compatibility, pag sinabi natin compatibility equation, yan yung geometric relation between the deformation. Okay? So, ito na yung sinasabi na additional. Okay? So, yung relation or geometric relation between deformation. Ayan. Yung compatibility equation natin. So, bakit ba natin ginagamit yan? Again, to visualize the restriction on deformation. It is often helpful to draw a sketch that exaggerates the magnitude of the deformations. Okay? Ayan. To visualize the restriction on deformation. So, yun yung pangalawa class. We have to derive compatibility equation. So, mamaya, atin itong susundin sa pagsusolve ng ating problems. And thirdly, use Hooke's law to express the deformation or yung strain in the compatibility equation in terms ng forces or stresses. So, after nung ating ma-derive yung compatibility equation, so ngayon we will use the concept of Hooke's law to express it in equation. Ayan, or yung mga deformation natin, we use the concept of Hooke's law para makapag-solve tayo. Okay? And last is solve the equilibrium and compatibility equation for the unknown forces. Okay, so yun. Magpuproceed tayo sa ating solving process. Okay? So that's the concept, that's the procedure on how we will going to solve the problem na under this statically indeterminate method. Okay? So let's now proceed to a sample problem para may apply natin yung ating natutunan. Okay? So for this sample problem, sabi dito, the concrete post in a figure below, so papakita natin, is reinforced actually with 4 symmetrically placed steel bars, each of cross-sectional area 900 mm squared. Compute the stress in each material when the 1,000 kilonewton actual load is applied. The moduli of elasticity are 200 GPa for steel and 14 GPa for concrete. Okay, so ito yung figure ng ating concrete post. Here is the figure. Okay, so as we can see here, we have this bearing plate on the top, and this broken line is the representation of our steel bars, and then this is the whole concrete post. Okay, and then the steel bar and the bearing plate, and then there is a load here that is 1,000 kilonewton. Okay, the top view. So these are our steel bars, okay, and then the concrete, and then the dimension is 300 by 300 mm. So square concrete post. Okay, so class, prepare your ball pen, calculator, and pen. So sabayan niyo ako sa pag-solve natin. Ano po? Yan. So handa na ba kayo? Let's start. Okay, so first, sa lahat ng ating sinosolve, so we always put the given, okay? So based sa ating problem, we have the area of steel, or A sub S, which is the area of steel, that is 900 mm squared, and modulus of elasticity of the steel, which is 200 GPa. We have also the modulus of elasticity of the concrete, which is 14 GPa, and of course we have this the force, or the applied force, which is 1,000 kilonewton. So as you can see, class, we don't have the area yet of the concrete. So anyways, we can solve for that. Okay. Yeah. So we are asked to find the stress in our steel and the stress that is experienced by our concrete. Okay, so let's proceed to our solution. Okay, so first we draw the free body diagram. Okay, so here class, okay, in this figure you can see the bearing plate and then the steel bars and then the concrete post. Okay, and then yung ating top view wherein we have the 300 by 300 dimension, and then the four steel bars, and then the concrete post. Okay, for solving for the area of the concrete, since we have four steel, and we are going to minus 8 or to subtract 8 doon sa ating buong area na para lang makuha natin yung sa concrete lang. So since we have a square concrete post, so the area of square is S square. So that's why we have this 300 square. And then we want to get only the area of concrete, okay? Since we have this steel bar here, so we need to subtract it from the area of the steel, of the concrete. I mean, so we have this 300 square minus 4. We have 4 steel bars there that each has a 900 mm squared area. So, okay, so 300 squared minus 4 times 900, we get this 800,400 mm square. Okay, so that is the area of our concrete. So now, next is, so we have this free body diagram. Since the problem, we are asked to find the stress, okay, in the concrete and the steel. So as we can remember, the formula for stress is force over area. So we have the area, the given area for steel is 900, and we just get this area of the concrete, which is 86,400 mm. So ang kukuhain naman natin is, the next is the force, okay? Para makuha na natin yung stress nila, okay? So first is sa step natin in solving statically indeterminate members, so we need to have the equation of the equilibrium. Okay, so as you can see, we put all the reaction here in our free body diagram. Since we have this applied force, which is 1,000 kilonewton. Ano bang tendency niyan, class? So, diba yan ay compressive force. So, ang tendency niyan, again, compressive force, it tend to shorten our body. It tend to shorten a certain body. Okay? So, ang mangyayari niyan, class, technically yan ay i-compress ang ating body ito or yung ating concrete force. So, let's say ang kanyang naging deformation is ito. So, from here, okay? So, bumaba siya ng ganun. Or shorten niya yung ating concrete post hanggang dito. Okay? Ayan. So, yung ating concept for the stress, syempre, pagka meron tayong applied force or external force in a certain body, the body is going to resist, okay? Or lalabanan niya yung applied force na yon para manatili sa equilibrium yung body na yan. Okay? So, mangyayari ngayong class, ayan. So, ito, lalaban si concrete. Siyempre, yan, si concrete. At hindi lang yun si concrete ang magre-resist sa 1,000 kilonewton. lalaban din kasi kasama sa concrete post na yan yung ating mga bakal or yung ating steel bar. So, syempre, apat yun. So, dito sa unang side is we have 2. Okay? Kaya yan ay 2 P sub S. And then dito sa kabilang side, we have also 2, which is 2. Yun nga, kaya 2 P sub S. Okay? So, and para mas malinaw, so ito siya. Okay? Kung makikita natin in a top view, so we have this steel bar na i-resist yung applied load, which is 1,000 kilonewton. So, pag-apply niyan diyan sa area na yan, so i-resist siya ng ating concrete, and then also yung ating mga steel bars. Okay? So, ayan, nakita na natin yung mga reaction. So, yan lang naman yung ating magiging reaction, the horizontal reaction. So, mean to say, class, we have this summation of forces, vertical reaction. So, we have this summation of forces vertical, okay, which is equals to 0, means to say we have this equilibrium, okay? So, all forces going up is positive and all forces going down is negative. So we have this 4P sub S plus the forces or the force in the concrete, the resisting force concrete minus the compressive force, which is 1,000 kilonewton, is equals to 0. Okay, so we have this equation. Okay, so the next one, class, is the compatibility equation. Again, compatibility equation is, ayan, ang focus na is yung ating, di ba siya yung ating geometric relation ng deformation. Okay, balikan natin yung ating system. So ito po, di ba? So, since ang kanyang, di ba, ang ating system is under ng statically indeterminate, meaning to say hindi sapat yung equation ng equilibrium. That's why we need the supportive equation or pang-support na equation, which is yan nga yung ating compatibility equation. So, since ito ay ang kanyang pinupunto is yung ating deformation, so ito, ipapakita yung relationship nito. So, ayan, di ba, alin ba yung kukuhanan natin ng deformation? Siyempre, yung ating concrete at saka yung steel natin. Since sila ay magkasama sa isang body, yung deformation ng ating steel is also equal sa deformation ng ating concrete since nasa isang body sila. So, therefore, class, we have the equation na yung delta S is equals to delta C or delta ng concrete. Okay? That, class, is our compatibility equation. So, yun naman yung magiging deformation nila, wala nang iba. So, yun lang. Okay, since we have this compressive force na 1,000 kilonewton. So, ngayon, ang sunod naman, class, once na we have na-derive na natin yung compatibility equation, so para ma-express natin yan, para ma-extract natin yan, we will use the concept of Hooke's law. So, yun yung next natin. Ngayon, class, di ba, remember, so, tingnan natin ang ating system. Di ba siya under ng normal or, ayan, so yung mga forces natin is, yan nga, we have compressive force or yan ay nasa axial deformation. Ano po? Ayan. So, kaya ang gagamitin natin is yung natatandaan natin na PL over AE. Ayan. So, we have this as sub S for steel and sub C for the concrete. Okay? So, yun lang naman yun. And then, since yung ating length, ano po, yung ating length is equal kasi yung haba ng or yung length nga ng deformation ng steel is also equal sa length ng deformation ng ating concrete since sila ay nasa isang body. Ano po? So, pwede natin i-disregard yun since mag-equal naman siya ng length. Okay? So, ngayon, sisimple na yung ating equation at mas madali natin siyang masasolve. kasi nag-eliminate tayo ng length. So ngayong class, ayan. So mangyayari ngayon is substitute na natin yung ating given. So we have this P sub S, which is ito yung hahanapin natin, yung ating force, over ng A, which is yung area ng ating steel na 900 mm squared, and yung kanyang modulus of elasticity na 200 GPa. And then for the concrete, we have the PC, and then yung kanyang area na nakuha natin kanina na 86,400 mm squared, and then yung kanyang modulus of elasticity na 14 GPa. Ngayon, ito kasi is PS and PC. Again, kung balikan natin class yung ating equation dun sa equilibrium, so we can express this PC in terms of PS. So, ito yung class. But PC is equals to 1,000 kN minus 4 times P sub S. Okay? So, yung ating equation kanina dun sa equilibrium. So, itin lang, inilipat-lipat. So, ngayon, pwede na natin siyang i-substitute doon. Okay? So, upon substituting, ano po? So, eto tataas doon. Okay? So, kaya yan, nag-substitute na tayo ng ating 1,000 kN minus 4 times P sub S, and then itong nasa P sub S, tumaas doon. So, which is, yan, 900 times 200, and then, yan. So, mangyayari, magka-cancel out yung mga units. Ano po? And then, ayan, upon solving, class, anong lalabas? Ayan. So, I hope na same tayo nang nakuha. Ayan. So, we have 93,283.3 283.5820 8955 223 Newton. So, yan yung akin. Ano? So, hindi ako nag-round off kasi class, ang aking ginagawa is doon ako sa dulo nag-round off with 4 decimal places, kagaya ng aking binabahagi sa inyo. So, naka-Newton. So, mamaya, sa bakit naka-Newton? So, pwede nyo na ma-express dyan in kilonewton. Pero sa akin kasi naka-Newton because mamaya makikita nyo kung bakit naka-Newton yung in-express niya. Okay, so ngayon, for PC, since we have the value ng PS, so PC naman, substitute lang natin doon sa equation na ginamit natin kanina, which is PC is equals to 1,000 kN minus yung ating 4 times the PS. We have the PS na 93,283.5820 8955 22.3 Newton. And then, i-process lang natin to and we will get this. Okay, so 626,000, okay, 865.67, 16, 41, 791 Newton. So, I hope na tayo ay same na nakuha. Ano po? You can express in kilonewton if you want. You can do so. Ano po? So, sa akin, naka-Newton lang ako. Okay. Ayan. So, mamaya kasi makikita natin. Okay, so ito na nga, since we have this the PS, which is the force in steel and force in the concrete, and we have the area in both steel and concrete, so we can solve for the stress. Okay, so substitute lang natin for stress in concrete. So we have the PC and AC, which is nga yung ating 626,000 865.67, 16, 41, 90, 791 Newton over ng ating 86,400 mm squared. And then, upon applying the operation, so we will get this. Ayan, class akin ay so, ayan, yan po yung dahilan kung bakit naka-Newton and mm. Kasi po, Newton mm, di ba? So, Newton mm squared is equal sa MPa. Yan. Kaya po, Newton ang aking ginamit. So, direkta kasi yan magiging MPa. Ayan. So, ang ating sagot with 4 decimal places is 7.2554 MPa. Yan yung ating stress for the concrete. Okay? So, for the steel naman, stress for the steel. So, we have this PS over ng AS. So, yung PS natin, which is 93,283.5820 8955 223 Newton over na 900 mm squared. Again, Newton mm squared is MPa. So, yeah. And then applying the operation, we have this 103.6484 MPa. And so, sorry, that is sigma C, sigma S, okay? Ayan. So, yan. Okay, palitan lang natin. Sigma, this is sigma S, sorry. Yeah, sigma S. So, yan. Ano po? Ayan. Sigma S. So that is our stress for the steel. Okay? And then, sige po, i-check natin kung tama ba yung ating sagot. So, ayan. So, tama po. We have the 7.224 MPa and 103.6484 MPa. So, that is our final answer. So, yan. Yan po ang ating statically indeterminate. So, ayun po ang ating concept, yun ang ating formula and the process on how we will solve this kind of problem, statically indeterminate member na yan po, yun yung ating solution. So I hope that you get something and you learn something from this tutorial, and don't forget to like, share, and subscribe for more tutorials. So thank you, class, and to God be all the glory. So thank you and keep safe, everyone. God richly bless you.